In note 7.8, we're looking at what's called natural logs. The reason they're called natural logs is because we're looking at a log with a base e of x. Well, that's what we're looking at first anyway. So anytime you have a log base e, remember that e is called the natural base. We call that a natural log. And sometimes you'll see it abbreviated ln. So log base e of x is the same thing as ln, which means natural log of x. So when working in your calculator, it's a lot easier to use this ln x button. So what I've done here is I have put in the y equals natural log of x, so that means log base e of x. And first off, pictures for me are 1,000 words, so let's look at the picture. This picture looks very much like the other log graphs that we've been looking at. Okay, so we know that probably this log has a asymptote here on our y-axis. And we can verify that by looking at the table, and I've picked out a couple of values here. Now, I started at a half because, as you can see, all of my negative x values have an error, including even 0 has an error because of, yes, that assumption we had is true, that asymptote. So we are going to have an asymptote on the y-axis for this guy. Okay, so I had you start with, I've adjusted my table because I had you start with a half, because if you start at 1, it kind of looks like it does something different. So looking at a half, my y value is about negative 0.7. Okay, and then coming down here, looking at x is 1, my y value is 0. Okay, looking at x is 3, my y value is about 1.1. And looking at x is 8, my y value is about 2.1. So unfortunately, with a base e, you can see as I scroll down, there's really no whole numbers here on the right. So we're going to do our best. I think that was 2.1. Yes. Okay, so plotting these points at x is a half, so that's a half. I have negative 0.7 for my y value, so that's about there. Okay, when x is 1, I have y 0, 1, 2, 3, about 1.1, and 4, 5, 6, 7, 8, about 2.1. So as you can tell, this graph is going to come down, hug that asymptote, and slowly but surely crawl all the way up. So very similarly to our other log graphs, the domain for this guy, because of the asymptote, is going to be x is greater than 0. It's just going to hug this line here but never touch it. Our range is going to be all real numbers because it's going to essentially go all the way down and all the way up eventually. Okay, our x-intercept is here at 1, 0. Y-intercept, hopefully you know, non-existent. There is none. No y-intercept because of this asymptote. It'll never cross through it. Okay, and our asymptote is the line x equals 0. Okay, so there's your basic characteristics of your natural log graph. So let's talk about some other things. So we've looked at transformations of other log graphs. How does this compare? Well, it's actually exactly the same. So if I give you log base e of something like x plus 1, since that plus 1 is not in parentheses, this graph is going to shift up 1. Okay, as you might have guessed. And you're all familiar with how to do this, so I'm not even going to take the time to do that. So looking at just maybe 2 more examples. If I have log base e of something like x plus 3 in parentheses, now since that's in the parentheses, that is going to shift left 3. Okay, that's an inside change, so that's a left by 3 movement. Okay, another example, if I have something like a negative on the outside, Okay, log base e, let's say x minus 2. So that negative on the outside is going to reflect over x, and the minus 2 on the outside is going to make it move down 2. Okay, and now be aware that you may see it written like this sometimes. So sometimes instead of writing it log base e, they might do something like they might use the ln notation. Natural log of, let's say, x minus 4. So it means the same thing though, it just means log base e. So if in your mind you have to replace that with a log base e, you can rewrite it, but it acts the same way. So that 2 is a stretch, a vertical stretch. So you might want to put a little v. Vertical stretch by 2. And that minus 4 in the parentheses moves it right 4.